Hello, this is Ipek Hokelar, and this is my CS2316 project. Have you ever wondered what's the best airport to fly from based on factors such as reliability, affordability, and more, so that you can have the quickest and cheapest trips? Today, with data-driven insights, I hope to find out. Did you know just in Denver last year there was a collective 969 years of wasted consumer time? As an international student and a travel enthusiast, I very often find myself in airports. So I chose this topic to be able to see if and what conveniences airports have that influences their flight prices. I hope to find some airports that are reliable, safe, and less costly in the process. Hopefully, this analysis will play part in my decision to choose a place to live after graduation, and hopefully, it will help you plan your vacation affordably and reliably. Initially, to find some answers, I hope to determine the correlations between the size of airport and the average flight price. My hypothesis was that these will be inversely correlated. I also want to determine the correlation between the reliability of airports and their flight prices. I hypothesize that airports with more air traffic will be cheaper and that airports with larger percentage of delayed flights will be more expensive due to a substantial loss in profit from the long run. I hypothesize that delayed flights will be mainly as a result of carrier count, and finally that airlines with most employees will have a smaller percentage of delayed flights due to an increase of manpower. My insights will address these hypotheses, but in the process, I hope to find or stumble on some more correlations. Starting off with the data collection, I initiated the search in the government website, the BTS, Bureau of Transportation Statistics, where I was able to find pretty much most of data information I was looking for. I also needed to find the airport size, and the closest metric I found was the runway lengths and widths in a database called AirportDB, saved in a JSON format. So I extracted that using an API key. From GitHub, I found general information about cities and their populations. Onto the data cleaning, the CSS dataset mainly posed issues with the NaN and empty values it had because it came from a government website. I used the standard nempy.nan data type and the methods. For my two datasets from HTML sources, I used requests to access the website and parse through the HTML table with beautiful soups, find, and find all modules. I also performed standard cleaning on these datasets that I haven't added the code for, but it included standardizing column names and values using .rename.insert.drop and more. Also, all numerical values were rounded to two significant figures for consistency across datasets for the future visualizations. And here's how I accessed the JSON database with 60K airports and information about their runways, communication frequencies, and more, and stored them in a dictionary and then a data frame. I hit my API token limit like 6 times when working with this dataset, and I even had to create 2 different emails. But it finally worked out, but the data was very, very messy from it. So onto its cleaning. This was by far the hardest data manipulation I had to do. I had to extract useful information from essentially JSONs within lists in a data frame column. I needed just 2 values, widths and lengths of runways. So I had to extract the tiny information needed using RE functions like re.findAll, string functions like the dataframe.string.extract. I utilized loops and other iterators such as .iteros. This task generally taught me to find creative ways to extract information that can't simply be done with a single pandas function. It trained my algorithmic thinking. And so moving on to the insights, addressing hypothesis 1, I calculated the relationship between the total airport runway length and the average fare. Pearson's correlation coefficient was used to determine the strength of the relationship between the two. The correlation I got was very low, that of 0.03. This showed that the total runway length per airport did not affect the average fare size. This strongly suggests that smaller private airports have higher prices and that larger ones have lower prices. This brings us on to our next insights, which will explore whether how busy an airport is, its air traffic affects its average airfares. Hence, I calculated the percentage of high traffic airports in the top 10% that have fares below the average airfare cost. The result I got was that nearly all of the airports, a whooping 97.22% out of the 10 busiest airports in the United States, had cheaper than average fare costs. This aligns with my second hypothesis, of that busier airports have lower prices. The reason for this could be that they have more commercial flights. Other reasons include that larger cities have busier airports and they usually have more efficient developed air transportation infrastructure and are home to some major airline companies such as Delta, United, and more. Therefore, this correlation shows that airport doesn't necessarily have to be bigger as proven by the rejection of hypothesis 1, but it does have to be busier and public to have cheaper prices. But now, does it have to be more reliable? To find out, with Insight 3, I examined the relationship between reliability and average fare price to answer the question of whether more money gets you planes that take off on time. And for this, I ordered the airports by the delay percentage and got the average fare price from the top and bottom airports. The results were that smaller private airports had higher reliability and higher fare prices overall. This makes sense. If you're willing to pay more, you will get a better service. Therefore, on average, reliability appears to be positively correlated to cost. So summarizing the previous three insights in a very cool visual, I made this 3D bubble graph that is plotting the average fare prices, total runway lengths, reliability, and air traffic per airport in a state and city. The color of the bubbles represents the fare cost, and the size of the bubble is the airport's physical size. You can filter your search of airports, let me put that video on, by pretty much anything. Example, say you're searching for the busiest airports in the US. You look at the z-axis and for the air traffic and see that the bubble is which one's the highest. Pressing on it, you see that it's Atlanta, Georgia, with 360k flights a month. You can look at its color and see that it has around average fare costs, and you can search for any airport this way. Once you find the one you're looking for, you can get all the information about it by just simply hovering over. This 3D bubble graph makes it easier to understand general correlations too. We can see that, for instance, the higher the reliability gets, the yellower and smaller are the bubbles. You can see that the higher the air traffic, the bigger the bubbles, so bigger airports do have more air traffic in general. And there's so many more correlations present in this graph. This one visualization is equivalent to 5 separate graphs, which makes it very, very cool and efficient to analyze, plus it looks really nice. Feel free to use it and find the airport that suits you best. I calculated the median number of employees per company, then I divided airlines into 2 groups, those that were below and above the median employee size. For each group, I extracted the median delay percentages. The results show that the airlines with more employees has a 22.22% median delay rate, whereas the airlines with less employees have a 20.9% rate. These results are very close and very surprising, as we would expect more employees to translate to less delays, as it would decrease carrier-related delays. However, this is not the case, meaning that more employees do not correlate to more reliable flights. Even so, slightly the opposite. Possibly other factors such as weather play a much larger role. This will be explored in Visual 2. I made a pie chart with the causes for flight delays. I summed all types of delays given the key according to their types. The results show that most delays happen due to aircraft arriving late. The second is due to carrier delays, which is surprising as previously we did not find that employee count and delays were correlated. However, it still accounts for 35.7% of delays, and there could be many other underlying reasons such as the unpredictability of employees that account for the non-impactful workforce. Therefore, if airlines want to increase their on-time percentages, they will have to target the late aircraft and carrier count categories. However, not through the increase of labor. This calls for further investigation for sure. In this insight, I ranked 260 airports for you based on reliability and affordability normalized by the population to find what's best and worst for travel. So, for the best cities to travel from per capita according to these metrics, we have New York, LA, Chicago, Houston, and Phoenix. Whereas the worst 5 airports are smaller cities that I've personally never heard of. Prescott Lincoln State College. I believe that reliability, cost, and location is one, if not the most important factors when booking flights. So feel free to explore this table to find your location of preference, and I will, put it on. And the reason I normalize it by population in this is because in phase 1, I stated that I will account for bias. In this case, larger cities tend to have more flights and delays simply due to their size. Normalizing by population adjusts for this, allowing smaller cities to be fairly compared. And finally, to summarize everything to see which states are best to travel from, I made this chloropleth map where I grouped the datasets by states, took the average of the ranks of all the airports in the state to determine which one ranks best. The states that contain the most reliable airports appear to be Massachusetts, Nevada, and the least reliable ones are Montana, Idaho, Iowa. This may be surprising at first, but it is important to keep in mind that some cities that are ranked high on the best airports ranking list that I just showed you, such as New York, LA, Chicago, also have considerably larger quantities of smaller, less reliable airports, bringing their overall average down. In conclusion, these insights have responded to all my hypotheses as listed in the left column. For next steps, this investigation made me have many more questions. For example, why doesn't a higher number of employees decrease carrier count delays? Or how do domestic and international flights differ? The main learning outcomes I've had could be split into 2, thinking and technical. Thinking skills that I've gained were algorithmic thinking when data cleaning with loops within loops, forward thinking when cleaning data sets to match the needed format for the inside calculations, and most importantly, accounting for bias. Technical skills that I've gained were using APIs, statistical models such as regression correlations, mean, median in real life, and complex visualizations such as bubble graphs. Thank you so much for listening.